In this video, we're going to go over Wiley Problem 5-12 from assignment 5QA. The problem is, a small can of soda contains 360 milliliters. Planet Earth contains about 320 cubic million miles, or 3.5 times 10 to the 20 gallons of water. That's our given information. The question is, how many cans of soda would it take to equal all the water on Planet A? I copied and pasted this from the Wiley problem. First of all, they say Planet A. I think they mean Planet Earth. I'm sure they used a template and wrote this problem, but that's okay. We're not going to let that hang us up. We're going to press forward. This is a classic dimensional analysis problem. As with any dimensional analysis problem, we're going to take our given information, apply our conversions, and get our target. The target for this first part is cans of soda. I think they tell us cubic miles. That's nice gee whiz information, but we're not going to use it to solve this problem. Gallons is going to be a lot more handy. We'll take gallons, go to liters, and then to milliliters. That's our given information. 1 can equals 360 milliliters. Our target is cans, so we're going to put cans on top, 360 milliliters on the bottom. Another conversion we'll need: 1 gallon equals 3.79 liters. Now you could have looked this up. Remember, if this were an assessment problem, this conversion would be given. Don't worry about memorizing it. How are we going to apply it? Before we apply it, we want to convert milliliters to liters. 1,000 milliliters equals 1 liter. That's a conversion you should probably memorize. So we take those two conversion factors and we apply them like this. Now, why did we do that? We want to cancel milliliters, we want to cancel liters. And applying the conversions in this manner does that for us. Milliliters cancel, liters cancel. We have cans on the top and gallons on the bottom. Now our next step is we want to get rid of gallons. We're given 3.5 times 10 to the 20 gallons of water. So in order for the gallons on the bottom to cancel, we're going to multiply by gallons. We're going to put gallons on the top. When we do this, gallons cancel. Our units left over are cans. So we apply our conversions in this way because we were asked to come up with cans. Numbers on the top get multiplied. Numbers on the bottom get divided. Take out your calculators, go ahead and do that calculation right now. I do have an answer, but you want to check it. Don't just believe me. Also, you're probably going to get this problem with different numbers, so you need to do the calculation yourself. Common sense says this number is going to be big. There's a lot of water on planet Earth. Cans are pretty small, so it's going to take a lot of them to fill that. If we end up with a small number, we'll know we made a mistake. Always apply common sense to your answer. It's a good check. The calculated answer I get is 3.7 times 10 to the 21st. Yeah, that's a pretty big number. We're going to use two significant figures because our answer, or our given information, the 3.5 times 10 to the 20, was 2 sig figs. That's the first part of the problem. Let's now look at the second. The second part says how many moles of cans this is. So we calculated 3.7 times 10 to the 21 cans. And when we think of a mole, it's usually atoms, molecules, or ions. But remember that a mole is a grouping of anything. It's just like a dozen, but a lot bigger. We're going to use Avogadro's number to convert our number of cans into moles. There's our given information. Now we know that 6.02 times 10 to the 23rd equals 1 mole. We're going to apply this so mole is on the top and cans is on the bottom. In this case, moles is our target unit. Cans cancel, multiply numbers on the top, divide numbers on the bottom. I get 0.0061 moles. Also, another way to express this, 6.1 times 10 to the minus 3 moles of cans. When you are given this type of problem, any numeric problem, the first thing you should think of is, will dimensional analysis work? Most of the time, it will. Also, don't make these problems too difficult. If you understand dimensional analysis, you take your given information, you set up your conversions, and you go. You don't have to think too much about it. As always, contact me, contact Corey, if you have any questions about this or any other Wiley problems. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.